All right, real quick walkthrough of the processes with insulin and glucagon. I wanted to draw this, but I don't have my little mount to use my camera at home, so I'm going to go through this and get it posted sooner rather than later. So these are in the notes, and I think this is going to maybe do it backwards from top and bottom from how we might have done it in class. But start with, I believe, insulin side, right? So remember, hormone is a message, and the action comes from the receptors, right? So high blood glucose is what is the input that triggers insulin release. Remember, insulin is the message that you have high blood glucose, okay? As we talked about, glucose targets all cells except for brain tissue, liver tissue, and increases glucose uptake. When we talk about glycogen production, we see that increase occurs in skeletal muscle and in liver. Now, we did not talk about the amino acid and protein synthesis, but worth noting that it's in there. But then we see liver enzymes producing triglycerides out of those glucose, or out of the when insulin is present. Net result, all of those is that blood sugar goes down. Whenever we think about feedback, remember we want to talk about negative and positive feedbacks. So positive feedback, as long as the blood glucose is still high, we are going to see insulin continue to be released. What's the negative feedback? Well, negative feedback is going to be a normal blood glucose, or one of the things that we could see actually happen is that leads to a low blood glucose. Now, the signal for low blood glucose, glucagon is released. Glucagon, what we see, and these aren't in the same order from lecture, but number one, gluconeogenesis. So in the liver, taking all sorts of other carbon precursors to be able to produce new glucose molecules. Also liver and skeletal muscle, but the skeletal muscle don't share. We see glycogen broken down. And again, keep in mind, glycogen on either side, that's a fast step because glycogen is glucose that is put together into long chains. So if we want to make it when insulin is around, all we're doing is we're linking glucose together. If we want to break glycogen down, all we're doing is ripping individual glucoses off. Triglyceride breakdown, so this is a slow process, and the reason that's a slow process is because triglycerides are not water soluble. The enzymes are, so it's inefficient. It takes a long period of time. Net result, we're going to see an increase in blood glucose, right? Positive feedback until we get back to normal, or when we get to that high blood glucose, right? So what we see is really, when we talk about whatever your blood glucose is, it's kind of a balance of how much insulin or glucagon is in your system, balancing whatever that set point of normal glucose